Hi everyone, welcome to Math 163. This is going to be the first section of notes. It corresponds to section 1.1 in your textbook. I am going to break it down by objective because it is a pretty long section. So this is the video for the first objective on functions. So you can follow along on your PowerPoint slides and take notes as you go. So I'll just go ahead and get started. So the first section is about functions. This section really should be a bit of review from algebra. So we'll go through it pretty quickly. So we'll start with the definition of a relation. A relation is a correspondence between two sets. It's not really any more specific than that. It's just the value of one variable related to the value of a second variable. So a couple ways to say that. X corresponds to y. X depends on y, x is the input, y is the output, so it's just this relationship between two things. So a couple of examples here are your education level and your income level. So I could give you an ordered pair for that. So let's say your education level is bachelor's and your income level is, I don't know, $60,000 a year. So those two things are related, the degree that you earn and your education level. I'm sorry, your education and your income level in some cases. Another example is the engine size in your car and the gas mileage. Those may be related. And some ways we're going to represent this are in an equation, a graph, and a map or mapping. Okay, so this is a map or mapping. It does represent ordered pairs. So if you follow the arrows here, you can see what the ordered pairs are. So Alaska corresponds to 7 representatives. Arizona corresponds to 8 representatives. Just follow the arrows like that. So this would be, your X value, and this would be your Y value. Okay, so here are the ordered pairs that are represented here. Okay, here are some others, a person and their phone number. You can see this Colleen person has 2 different phone numbers. An animal and its life expectancy. So those are relations. To be a little more specific, now we're going to define a function. This is for each X value, there's exactly one Y value. So in this mapping here, you can see for each X value, there's only one arrow coming out, and that's what makes it a function, not just a relation. Let me write that for you. So another way to define that is you've only got one arrow coming out from each X. Okay, the X values are also called the domain, and the Y values are called the range. So now we want to determine whether a relation represents a function. Anything that can be drawn in a mapping is certainly a relation. What we want to do is see if this is also a function. And to figure that out, what we want to do is see whether there's only one arrow coming out from each X value or not. And that does appear to be the case here. So this is a function. Whoa, my pen's going crazy. Sorry. So yes, this is a function. Okay, how about this one? Think about this one. Is this one a function? Yes or no? And the answer is yes, this one is a function as well. And that's because we have only one arrow coming out from each X. So don't let this 23 down here confuse you. It is okay to have 2 arrows pointing to the same number, not 2 arrows coming out from the same number though. Okay, how about this one? Function, yes or no? This one is not a function. And the reason is because there are 2 arrows coming out from this 0.86 right here, So this is considered a repeated x value. It goes to two different y values, so this is not a function. It is, however, a relation still. Okay, how about these ordered pairs? Do these represent functions? Well, I could certainly draw these into a mapping to figure that out, or I can just look at my x values and see if any x values are repeated. Okay, so look at this first one. I'm just looking at x values 2, 4, 3, and 2. This 2 is repeated, so that would be similar to two arrows coming out from the same x value. So this one is not a function. Next one, look at your x values, -2, 4, 3, and 2. Function or not? Yes, this one is a function because none of our x values are repeated. Okay, next one, 2, 4, 3, and 2. Hey, that's the same as the first one. So no, duh. Just kidding. All right, so the other part of this question is, if it is a function, state the domain and range. So the domain, remember, is our x values. This is just a list. So it would be -2, 4, 3, and 2. And the range would be 3, 1, -2, and -1. So this is a list of our x values, a list of our y values. They're not ordered pairs anymore, so you don't have the parentheses, just the brackets. All right, next we'll look at how to tell if something is a function or not from an equation. This is a little more abstract. So determine if the equation y equals -1/2 x minus 3 defines y as a function of x. So what we want to think about is, if we create some x values here, is there any way to get two different y values from the same x value? So you can kind of think of making a table here. Let me make something right here. So let's plug in something nice right here. I don't know, let's plug in 4. So if I plug in 4 right here, -1/2 times 4, that's -2, minus 3, and work that out, so that's -5. Is there any way to plug in 4 and get a different answer besides -5? Well, the answer to that is no. Every time I plug in 4, I'm going to get -5. So there's no way that I could have two arrows coming out from the 4 and pointing to different y values. Okay, let's test it one more time with something else, maybe like -6. So plug in -6, -1/2 times -6 is what? +3 minus 3. That always gives me 0. There's no way to get any other answer out of that. And the same will be true for any x value that I invent here. If I plug in that x value, I'll always get the same predictable y value out of it, which means that this is in fact a function. Okay, let's look at another one. Determine if the equation x equals 2y² plus 1 defines y as a function of x. To see this a little better, I am going to go ahead and solve it for y. So get y by itself. Subtract the 1 on both sides here, so I get x minus 1 equals 2y². Divide both sides by 2. So I can think of this as y² equals, let's divide out this 2, so that'll be 1/2 x minus 1/2. Yuck. Take the square root of both sides to get y by itself. You do need plus or minus when you take the square root. Okay, so here's my equation. If I now try to make a table for this, let's see. What's an x value that I can plug in? Let's go with 4 again. So 1/2 times, I'm plugging in 4 right here. 1/2 times 4, that's 2 minus 1/2. So 3/2, right? Square root of 3/2. But it's plus or minus square root of 3/2. So for this x value that I plugged in, I actually am getting two separate answers, positive square root of 3/2, whatever that is, and also negative square root of 3/2. So this is like two different arrows coming out from the 4, if you were drawing a mapping to two different answers. So would you say that this is a function or not? The answer is no, this is not going to be a function, because you have those two arrows coming out from the same x value. Let me draw this as a mapping a little more. Okay, so no, this is not a function. All right, so watch the next video for the second objective in the first section, so section 1.1.